Hi AP Calculus class. Today I'm going to do a little bit more difficult example of a definite integral. Here is the problem, and alright, let's get started. So first of all, we should just take the integral before even looking at our bounds, which is 1 through 5. We should take the integral of this. Now, how do we do that? Well, we see here like the anti-chain rule, like you have learned before. So what we need to do here is we need to make sure that the derivative of the inner function is accounted for. Now, the derivative of this inner function is simply 10x. Because we take the 2 down and we're, 10x. But here we only have the x. We need the 10. So let's just add the 10. But we're not done yet. We can't just add numbers as we want. We need to account for this 10. So to do that, we 1 over 10. Since this times this equals 1, it is accounted for. Alright, so now that we do that, we can just do this simple integration of the function. So we have 1 over 10. Our bound is 1 through 5 still. And all we need to do is 5x squared plus 2, raise it to the power of 2, and divide it by 2, or multiply it by 1/2. This is what we get. Alright, now we apply the second fundamental theorem of calculus by plugging in each of the bounds. Alright, but we cannot forget this part, so I'm just going to put it here right now. And big parentheses. So just make sure the steps are clear for you. Okay, so we just plug it in. Don't forget your plus c, that's very important. Minus, like the fundamental theorem of calculus says, minus, plug in the 1, plus c, and our c's cancel out. Now, I'm just, I really can't be bothered, so I'm just going to use my calculator. Like that. So I can get the first part, which is 8064.5 minus 24, and of course we need to divide it by 10 or multiply it by 1 over 10. That's very important. And the final answer of this should be 804. This is the answer to your integral. Thank you for listening. I hope this was helpful. So in this video, just to wrap up, we focused on using the anti-chain rule to find the integral. Just make sure that the derivative of this function is present somewhere within the integrand, and if not, then you can easily add a constant, but make sure to account for the constant outside. Some problems are a bit too hard, so a problem to fix here would be learning U substitution. I'm not sure whether you will learn it in class or not, but U substitution is a useful, can be a bit confusing, but it can be a useful way to doing more complicated anti-chain rules. Alright, thank you, and I hope this was helpful.